All right, so today we're going to learn about equivalent Boolean expressions. And today is more of an exploration of this as an idea. So while there will be some interaction, there won't be as much as when we move on to investigate the examples and then move on to practicing. So stick with me. There will be some interactive slides here as we move along, but not as many as some of the other lectures. Um, I would like to at some point talk about the AP pacing guide. Maybe I'll save the last 5 minutes or so for those of you who care about the AP exam. So we'll come back to that. But I want to kind of get started on this new lesson. So again, equivalent Boolean expressions. So last week we solved this problem together. We wanted to implement this program where we wanted to decide if I could ride the roller coaster. And we knew that that depended both on my height and my age. It had to be within a certain maximum. Um, but what if instead of determining if we can ride the roller coaster, what if I wanted to change this Boolean expression so that I can store this in a variable that represented that I could not? So we're going to talk about negation and how we can use negation in order to create equivalent Boolean expressions. So let's consider this code segment. This is from CodeHS. Um, so here's just plain old Java. Let me break this down into something more visual. So what this is saying is I have this statement here that creates a Boolean expression that is going to store it into this variable called cannot ride, this Boolean variable called cannot ride. And cannot ride is going to get the value of this compound Boolean expression, not tall enough or not old enough. So if either of these sides is true, I know that I cannot ride, right? So let's take in this scenario. So what if tall enough is true and old enough is false? Well, we would just do the same thing as we have been doing, right? We'll bring down those values. So tall enough at this point is true, so we'll bring that down. But notice that we have a not in front of it. So we need to negate that true. So we'll take the opposite of true, which is false. And then um, we know that either side of a compound Boolean expression can be true for the whole thing to be true. So I don't short circuit yet, right? This is false, but I see it's an or. I can still have what true over here and have the whole thing be true. So I'm going to keep going. I'm going to bring down the value stored in the variable old enough. So false. So now I have false or false. At this point, I know that both sides are false, so the whole thing has to be false. Oh, sorry. I forgot that there was a not here. So that's going to negate that false. I lied. Okay, so that's going to be true, right? Not false is true. So now I have at least one true in my or statement. So that's actually going to make the whole thing true. So now we have the Boolean value or the Boolean variable cannot ride is going to get the Boolean value true. So that's what we wind up with. And so we can conclude from this that the user cannot ride the ride, right? Because cannot ride is true. Okay, cool. This is all kind of stuff we knew already, how to do this. That's what we did last lesson. But it turns out that we can write the previous Boolean expression in a different way that is equivalent, okay? So let's see how we can do this. Okay, so these two statements turn out to be equivalent expressions. So the one on the top is the one that we saw originally, right? Not tall enough or not old enough. The one on the bottom is actually an equivalent statement. And I don't want you to worry about how that works yet. I'm going to show you. But I just want you to think about which one seems simpler to think about and evaluate, the one on the top or the one on the bottom. So what you're going to do at this point is you're going to take this little star icon and you're going to drag it next to the statement that you think is simpler to think about and to evaluate. Give you a moment to do that. All right, take about 10 more seconds if you haven't already located which one is the easiest. All right, so it seems like most of y'all agree that the bottom one is a little bit more simple to think about. So we just have like a plain Boolean, like not negated inside at all, tall and old enough. And then we just negate, we take the opposite. Um, that one seems a little simpler to me as well. One person thought maybe the top is a little easier. To me, it's a little harder just because you have to negate two sides and then you have to take an or. That seems a little bit more confusing to me, but I'm not going to say that you're wrong for thinking that this one's easier. That's totally fine. But I think most people think that this is a little bit easier to think about. And so sometimes it is worth finding these equivalent expressions just for practicality. Now, on the AP test, they're just going to have you convert um, Boolean expressions to an equivalent one, even if it's to a harder one to think about. And so that's why we are going to practice doing it in both directions. But you'll notice that there is some utility just because one version is always a little bit easier to think about. So we're going to be talking about the laws behind what allows us to find these equivalent Boolean expressions. Right now, it's a mystery to us how we actually like figure this out, but we're going to figure this out through something called De Morgan's laws. And so Augustus De Morgan was this British mathematician and logician who is responsible for these laws. He was around during the 1800s, lived quite long for that time. And not only was he a mathematician and logician, but he actually was a teacher as well. A lot of different popular names in math and science studied underneath him. One popular name is Ada Lovelace, who is known as the first computer programmer. Now, there weren't computers around in the 1800s, but she came up with the concepts that kind of underlie what it means to program a computer. And you'll notice that we're using De Morgan's laws too, and obviously there weren't computers back then either, but we're using these concepts that were developed back then behind the logic of computer programming. So yeah, it's pretty cool. So let's go ahead and investigate what De Morgan's laws are and how they help us out. So De Morgan's laws show how we can negate ands as well as ors in compound Boolean expressions. And so when we do that, when we negate ands and ors, we can also find an equivalent Boolean expression that matches our first statement. So I know this is a little, this doesn't really like tell you how this works, but for now, just kind of trust me in that not and A and B is the same as not A or not B. Okay, so this is the actual like law. And then here's a second one, not A or B is the same as not A and not B. Okay, so right now I haven't really told you how this works yet. These are just the two laws, but we're going to be investigating how it is that we actually get from this side on the left to that side on the right, and saying that those two are equivalent. Okay, here we go. So this slide is basically the same thing as the previous slide, but now it's written in Java notation, right? We've got not A and B is the same as, is the equal to not A or not B, okay? And then not A or B is the same as not A and not B. Okay, so haven't given you really anything new here. I just kind of rewrote it in Java. Let's now break it down. Okay, so we're going to take that first one, not A and B. Okay, so we're negating A and B. Okay, I'm not going to go through the proof because I think that's more information than what you need. But if you want to see the proof, that is in the CodeHS video. I'm going to show you the process. And I think the process is pretty easy once you kind of see it. And I think it makes sense. So here are the steps. What I would like you to do is think of this as distribution of the not operator. Okay, so the not operator again is this exclamation mark. And what I'm going to do is I'm first going to distribute the not operator to each term inside of the compound expression. So I'm going to distribute it to the A and I'm going to distribute it to the B. So it's going to become this, right? I'm not done yet, though. I'm not saying that these two things are equivalent. I'm just showing the steps. So I've distributed that not to both of the elements. There's one more step I have to do. I need to negate the and operator, which means I'm going to switch it from an and to an or. Okay, so I'm going to do that. And that's it. That's all I have to do. I'm basically just negating each element inside, including the and operator. Okay, so I'm going to conclude that these two things are equivalent. And remember that one in the middle is just an intermediary step. I'm not saying that this is equivalent to the top and the bottom. Now, you are going to do one of these on your own, but I'm going to show you a couple more. So the next one, I'm going to show you how it works for not A or B. Okay, so I have not A or B. I'm going to go through the same process here. So the first step is I'm going to distribute the not operator, right? So I'm going to distribute not to A and I'm going to distribute not to B. So now I have not A or B. Then I want to change the or to an and. I need to negate that. Okay. And then I'm done. Two simple steps. Bring in the not to the actual Boolean components A and B, and then negate the operator inside. So flipping ands to ors and flipping ors to ands, essentially. And then we can conclude that these two are equivalent. All right, I'm going to go the other way now. What about the other direction? You'll notice that I went from kind of like the simplified version to the one that was harder to think about. But usually I want to kind of simplify, I mean, for my own sake. So what if I wanted to do that? Okay, so what I want to do is I'm going to take that common operator of not, and I'm going to distribute it outside of the parentheses. Okay, so I move that outside. And then I want to do the same thing with my or operator. I want to flip it to an and. Okay, and that's actually it. That's all I got to do. And then I can conclude that those two things are indeed the same. All right, so I know it's not helpful to kind of just watch me talk about it. So I would like you to do the next one. Um, so show the steps. I included what to do on the right-hand side. You just have to write the intermediary step and then the final answer on step number 2. So I'll give you a moment to do that. All right, awesome. So it looks like you all pretty much got it. Don't worry if you didn't complete it. Come back to the screen that I'm sharing at this point, and I'm going to go ahead and share one of the answers. And so the student recognized that they had to bring out that not operator outside of the parentheses, and then come down and flip the and to an or, and finally arriving upon not A or B. And that is equivalent to the top statement here. Awesome. Great job, everyone. So let's try one more that actually has Java syntax. So in this one, we have a Boolean variable, cannot night bike, and it is going to be set to the result of this Boolean expression. Not has headlight or has bike light. So go ahead and take those same 2 steps. I didn't write them this time, and see if you can write the steps here. All right, cool. Don't worry if you didn't finish. I see that most of y'all are on the right path. Just for the sake of time, I'm just going to kind of show you one student's answer. Actually, first, I'm going to show you another student. I realized that I said write the steps, and the student did. But I kind of wanted to show the steps first. So thank you to that student for doing that. So the first step is to distribute the not into the elements inside. So that's what the student did. You can see that this not got distributed to has headlight and it got distributed to has bike light. So you can see that both those Boolean elements inside is now negated. And then the other step is to change the ors to and. And so we can see that this or is now flipped to an and. And the final statement is not has headlight and not has bike light. And that is the same as this top Boolean expression. So these are equivalent Boolean expressions. Awesome. Are we supposed to include the parentheses after we distribute the not? You could take them out. It doesn't matter. You can keep them in or leave them out. Good question. All right. Let's see. All right. So yeah, that's the answer. And then we can say that it's equivalent. Yes, awesome. All right, so key takeaways from today. We can use De Morgan's laws to negate ands as well as ors, meaning that we just flip them. Ands become ors become ands. And this helps us to find equivalent Boolean expressions. You saw that some expressions are simpler than others, but the AP exam may ask you to go in either direction. They may take a simple one and have you find the not so simple one, or they'll have you simplify. But they will ask you to find equivalent Boolean expressions on the AP exam. Um, I don't know how many, maybe they'll just do one or two questions like that. All right, so to wrap up, watch the intro video on CodeHS and take the check for understanding quiz. Like I said, that's going to be part of your participation grade. Next time, we will investigate the examples on CodeHS. At this point, I am going to stop the recording and actually I'll just keep recording. But to those of you who are taking the AP exam, I'd like you to stick around. Those who are not, you're free to go. I'm just going to talk about AP exam pacing and what you can do to make sure that you are on track to study everything you need to by the time the AP exam rolls around. If getting a high score is one of your goals. But again, don't worry if you don't get a high score because college admissions offices are really just worried about are you taking classes that challenge you. Uh, the exam score itself doesn't matter as much. Okay, so I posted this on Google Classroom as well, but I wanted to make sure that you all knew that you had this at your disposal. So the College Board recognizes that every single one person is pretty much behind, and they came up with this guide for flipped classrooms or self-study. And so if I click on this, it comes up with a guide to keep you on track. So you'll notice that when I was trying to kind of rush us along, I was on track to finish up Unit 3 before our first semester ended. And so we would have started here on 4.1. But I decided to slow down because it's not everyone's goal to take the AP exam. And I just want to make sure that everyone has a good time and doesn't want to stress out and actually learn something. Um, so if you start this plan today, notice you will have to kind of catch up a little bit. But basically, they give you a schedule for what topics to study. And notice it'll say AP Daily Video. These are available on your AP Classroom on College Board. So what I'd like you all to do for like kind of an unofficial homework assignment is to log into your College Board AP Classroom and let me know if you were able to access these videos. I'm not sure if like I have to assign them to you or something, or if you're just able to access them yourself. And I want to make sure that you have access to those at your own pace. So if I look at this, this is going to look a little different because I'm a teacher account, not a student account. But I do have access to all these different like resources, like the daily AP videos and things like that. Um, so yeah, if I go to Unit 4, which is where they're saying to start, I see the daily videos and then I see the topic questions that I can review as well. Um, so what I'd like you to do for your unofficial homework is basically just to log in and try to find these resources. Okay, Martin says he has access to them. Awesome. Do you also have access to the topic questions here for like your practice? Or is it just the videos? No. Okay, so those I might have to assign, but at least for now you can get started looking at the videos. Um, yeah, I probably have, yeah, okay, I see that there are assessments to actually assign. So I can just assign all of these at once that are just due by the end of the semester. So you can kind of do them at your own pace. Um, but yeah, if your objective, your personal objective is to cover all the stuff that is normally covered in an AP class, this is kind of like a quick way to do it. I wouldn't just say, okay, watch these videos and then you're done learning. Um, but like in a pinch, I guess like this is how you might go about it. And so they're providing these videos to you. Notice that they don't have all the videos done yet because they're kind of developing it on the fly. So you'll notice that they haven't yet, they've only covered up until unit 6. And so they're currently working on those last 3 units, and those will become available as they become available. So yeah, I just wanted you all to know that this pacing guide exists for you to follow and that those resources exist for you to kind of self-study at your own pace. Yeah, but for the purpose of this class, we will probably wind up ending at like unit 6 or so, 5 or 6. We probably won't make it beyond that. We'll see how it goes though. All right. Let me know if you have any questions about that, and I will make sure to set up the topic questions for you to take at your own pace. It will not be part of your grade for this class. It's just for your own personal learning as you prepare for that AP exam. All right, that's all I have for y'all. When we come back on Wednesday, we'll investigate some of the coding examples together from 3.6.